Well, good afternoon, everyone. Welcome to the SAME DC Post First Friday. My name is Whitney Stoll. I'm the DC Post president. Welcome to the August First Friday webinar. Thank you for joining us here today for Trust But Verify, Side Channel Monitoring for Supply Chain Resiliency with our presenters, Dr. Ben Amaba and Dr. Dominic Forte from FINS, the Florida Institute for National Security, which is a division of the University of Florida. Joined by me is Samantha Long and Bree Beal, who are behind the scenes monitoring our webinar today and monitoring the chat. So we have participants from around the world logged in for this event, so hopefully ready to learn today's First Friday. So please join me in welcoming our guest presenters. Drs. Amabe and Forte will explore supply chain risks, malicious components, vulnerable detections, and monitoring platforms with a focus on scaling, real-time monitoring, and AI talent development. It's a big topic we're all very interested in learning more about. But first, to start by welcoming you to the First Friday webinar series, which is provided to you through SAME's commitment to offering the AEC community effective training, development, and networking programs. The DC Post is helping sustain the future of the profession with these monthly education-focused sessions to deliver topical and relevant content to our industry. So thank you all for joining us here today as we start our program. So please feel free to use the chat to introduce yourself, share your LinkedIn profile and contact information and where you're calling in from to everyone and throughout the presentation. Ask questions so we can address them during our Q&A portion at the end. And also for those using the WebEx platform, you have the option to save the chat by going up this File and Save Chat. And you may notice we are recording the session, so we will post the webinar to our YouTube channel later on this month, and we'll send you the slides as well as your PDH certificate as soon as the webinar ends. So we're glad to offer you an hour of education and virtual training, regardless of where you're attending from today. But as we start, let's start with a moment of silence to remember our active duty military, first responders, and all who need our care and thoughts throughout the world right now. Thank you. And please join me for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. I'd like to take a moment to thank our DC Post annual Platinum and First Friday sponsor, Fox Rothschild. We truly appreciate your support. We cannot put on these events without you and are grateful for your outstanding support and sponsorship for making this program possible. Your support today helps us meet our society goals, including providing educational content for our members, industry and government engagement, building resilient communities, connecting our future leaders through our student and young member groups, enriching the STEM pipeline, and preparing our military and veterans for life after service. If you're not already a DC Post sponsor and like to support our post with the annual sponsorship, we'd love to add your name to the slide for future programs and events throughout the year. Our annual Platinum sponsors and First Friday sponsors help support this webinar with free registration for SAME members and full-time students. So please visit our website for more information about sponsorship levels and how you can get back to the SAME community through your sponsorship. And now it's time for the main program. And please note, this program does provide one professional development hour from the DC Post. So look for an email with the subject line, document delivery from SAME DC and Eventbrite with a copy of our program slides, your PDH certificate, and an opt-in list of attendees who pre-registered for this session. We are recording this webinar and we will post a video on our website later on. So I'm not going to read the objectives, learning objectives on the slide, since most of you saw the objectives when you registered. Instead, I want to introduce to you our featured speakers in just a moment. And when I do the introduction, if you haven't done so already, please use the chat, introduce yourself, share any relevant contact information, your LinkedIn profile, and where you're calling in from. This is your webinar series to help you learn about this special topic and how you expand your business network throughout the program. And please use the chat during the presentation to share comments and ask questions for our presenters. If there is a particular slide you'd like to talk about, share that detail in your question. We'll save those questions in the chat for the end of the program. And by the way, don't forget to save the chat before you exit the webinar. And now please let me welcome our presenters. So Dr. Ben Amaba is an expert in industrial systems and software engineering and a distinguished fellow with the Institute of Industrial and Systems Engineers. He's a licensed PE, lead accredited professional, and holds certifications in corporate strategy and production management. He also has published work in AI and cybersecurity. And Dr. Dominic Forte is a professor and a Stephen A. Yatoro Facility Fellow in Electrical and Computer Engineering at the University of Florida, and Associate Director of FINS. He specializes in hardware security, has over 200 publications, 20 patents, and has received multiple distinguished industry awards focused on his research and exploration into cybersecurity technology. So welcome, Dr. Amaba and Dr. Forte. Now I'm going to turn the program over to you.
Well, thank you very much, Whitney. I really appreciate your time, as well as Breeze and Samantha's impeccable organization. I do want to, again, thank Fox Rothschild for sponsoring this event, as well as the Society of American Military Engineers. Along with that, I'd like to also thank the National Society of Professional Engineers, as well as NICET, who has enabled this group and consortium to put this presentation together. So with that, I'm going to start sharing my screen into the PowerPoint mode. Hopefully everybody has seen this. It does have our contact information. We've put it in the chat as well. And I'll try to go quickly through this so that you get the main message. I really feel this is one of the most important things for the Society of American Military Engineers, as well as other professional engineers across the industry. Why today we're going to talk about, and why is it so important? Because I think the impact is kind of seen in events like CrowdStrike, but the magnitude of that impact, I think, will startle many of you on this call. I want to talk to you about the how. There's been many organizations that we've gone around the United States to say, how is the best practices done? But more importantly, how do we converge those best practices to actually protect the public's wealth, safety, security, and welfare? And then what's next? That's an action that sometimes we miss. We can talk about the why and its urgency, how we've done in the past, but what's next for this audience? Because what's different about this audience, unlike other professionals, is there's no gray area. It is clearly our goal to take the veterans that understand domestically and internationally how to protect our infrastructure. With that, I will go to the next screen. Because one of the things I always want to do as an engineer, and a lot of us here, we benefit not only of the work of the engineer and technologist, but the smart work, right? We don't want to stress ourselves. We want to do the right things right. And on this screen, one of the more important screens as we get started, we've done this in several cities. In fact, the barcode to the right side of the screen at the top is an event we did 2 weeks ago in Huntsville, Alabama, for several engineers, as well as Miami, Florida, for several engineers in Florida. On the lower barcode is what the National Society of Professional Engineers, the Society of American Military Engineers, and NICET have put together, called the Systems and Software Integration, as one of our action items. Now let me get started. Why are we here today and the urgency? The world is obsessed with AI, but they forget the flip side of the coin called cybersecurity. Wherever there's a hero, there is a villain. And what we've discovered is that 50% of downtime is attributed to industrial code. And what does that mean? And we'll elicit and elaborate on that as we go forward. And cybersecurity now is in the top of all executives' minds, as well as leaders' mind, that the cybersecurity breaches are the #1 cause of unplanned downtime. And what is that costing us, our institution, and the public? On average, it's $4.2 million an hour is the average cost of that downtime reported from C-level executives. When you start introducing these downtimes into critical infrastructure, it can as much as double. Now, what we all know is that we've got to change people, process, and technology. But it's almost become a cliche because we don't really understand the surrounding envelope that morphs those to get better results, mission readiness, while improving cost and revenue. Today, we're going to talk not only about software, but hardware and the people that are behind that. So by dynamically changing the software, hardware, and processes, we're able to actually react to the changes that we see in the world today. Where are we today? The Society of American Military Engineers is one of the first lines of defense for our national security infrastructure. You can see that on the left. We've been doing it for the analog world for 100 years, and we continue to do that. Today, there are 16 infrastructures at risk. You can see them in the middle. And to the right, because our software, the world is being eaten by software, nefarious, bad actors, APT, advanced persistent threats, and nation state attacks are breaching these digital worlds to attack our infrastructure. And what's some of the causes of that? Although we're obsessed with the productivity of artificial intelligence, that's only one side of the coin. Again, anytime there's a hero, there's generally a villain. On the left side, there's a chart that we've been studying engineers for quite some time. They've enveloped their work from design to commissioning to even decommissioning, where our analog world is surrounded by software. But more importantly, what's really grown in the last 5 to 10 years, especially with artificial intelligence in the business to consumer and now business to business, is artificial intelligence. In fact, a majority of studies show that 75% of staff feel they are pressured to use generative AI despite identified security risks. In fact, I love the animation to the right. When you ask who loves AI, there are thousands and thousands of volunteers. In fact, one colleague said there are 10 billion AI experts in the world, yet there are only 8 billion people in the world. When you come to the second question, who is willing to deal with the ethical guidelines of AI? There is no sound from the audience. But more importantly, when it gets to execution, who is willing to take the responsibility for the decisions of these algorithms and emerging technologies? I can say today that that first line of defense are the engineers. It will not be the legal profession, the medical profession, or even the business profession. At the end of the day, engineers, such on this call, actually have no gray areas. It is black and white. Does it work, and does it protect the public's health, safety, security, and welfare? Now, when we look back at two major laws, Moore's Law helped us accelerate information technology by increasing the capacity of hardware. We then learned from Metcalfe's Law, by connecting those series of hardware, we're able to take another leap. But unbeknownst to many people, in 2008, the idea of reuse or open source software began to accelerate emerging technology such as AI. In fact, in yellow, if open source software didn't exist, companies would spend 3.5 up to 5 times more on software than they currently do. But what is really interesting, more precisely, that results show that a cost of $4.15 billion if society had to replace these open source software today. And if we actually had to redo them from scratch, it would be $8.8 trillion. So what's the message behind there? Hardware, networking, and open source software. We cannot turn back the arms or hands of time, and that we must step forward into the future. In stepping forward into the future, this is one of the most illustrative charts of where we are today and why we're here at this webinar with the Society of American Military Engineers. In 2006, many of the high-tech companies were looking at a software engineering license to add to the traditional engineering licenses from nuclear to civil to mechanical to aerospace. By 2013 to 2018, we actually had a software professional engineering license to monitor the integrity and cybersecurity breaches that often were predicted. But by 2018, the dynamics changed. Not only did we use open source software to hopefully at least scan and have several eyes look at the software, the Department of Defense embraced the reusability benefits in open source software, and we started moving forward. But by the year 2020 and 2021, although the teams within the United States and the Department of Defense and our infrastructure were collaborating, we discovered that nefarious people would enter the world of open source software with other actions in mind. And today, malware and vulnerabilities, or cybersecurity, are growing at 742%. This is kind of worrisome. In fact, most people don't know the impact. Today, cybercrime has skyrocketed to $6 trillion in 2021, and it continues to grow. Today, that forecasted market by 2025 could be as high, if not higher, than $10 trillion today. We have identified it, but will we take actions from this call? Vulnerabilities and malware, much less outages, we have all seen the impact to our daily lives. As of 2021, there's been an executive order on improving the nation's cybersecurity. But even today, that many of us experience not just a vulnerability or malware, a simple outage in CrowdStrike took down our global supply chain and still exists today. And Fortune 500 companies, outside of economic benefits of $5.4 billion, it is unfathomable to see what the safety of the United States has been put in jeopardy for. Because of that, the national cybersecurity could not blame the end user. The software liability has to belong to somebody. It's got to be somebody that has reasonable knowledge, that is committed to the public's health, safety, security, and welfare. That responsibility should be placed on stakeholders which are the most capable of taking action to prevent bad outcomes, not on the end users that often bear the consequences of insecure software, nor on the open source developer of a component that is integrated into commercial product. We see professional engineers who protect the entire system, including the hardware, network, people, and environment, always go above and beyond the duty, and now are going beyond the duty of the software and systems and set the minimum standard of care. Now, one of the areas of the executive order, and we'll just go down one thread because we'll show you the other QR code that'll give you access to all of the other sections. But I'm particularly interested in talking about Section 4. One of the best ways we can prevent and some of the vulnerabilities and malware is understanding what is coming down the pike, enhancing the software supply chain. By understanding the raw materials that come into our software supply chain, we can mitigate or at least prevent many of the vulnerabilities that are being exploited. In fact, 96% of the vulnerabilities actually have a fix out there today, and most people don't recognize it. We need to understand the measure and the objective and make vendors actually liable for the capability that they offer and match that measure and objective. Today, Sonatype is doing that with their current attestations with the software supply chain. In fact, so much so, even Europe has an attestation form, whether you're an integrator, developer, hardware, software, or even the human factors and process. Attestations are coming out to say that we must comply to at least a minimum standard of care to protect the public's health, safety, and security. In fact, we can't just hit the bottom line or the minimum standard of care. As we know, nefarious individuals are constantly using even the emerging technology of AI to breach the systems that we're there to protect. We must go deeper, where certain vulnerability databases only look at 55,000. We've discovered there's over 38 million out there. So every day we must get deeper and broader in the technology we are looking at. What we've also discovered in our research, the software supply chain goes more than just what's coming into the pipe. Although we do try to do prevention techniques to prevent that vulnerability or malware entering into the software supply chain, sometimes it makes it to the backbone of our development process. There we need to isolate it in the backbone and then remediate it or mitigate it should it come out on the other side of the operations. And we've got to have milestones within that software supply chain to actually catch these vulnerabilities and malware. I'm a big proponent, and I pulled out this slide. It's always prevention first. If we can prevent it before it gets into our system, it does a world of significance. And we've seen it in actual case studies. In a leading financial institution that spent over $2 million in an in-house solution in an isolated world failed to detect several threats. By using a repository firewall, we identified an additional 72 malicious packages compromising 11,000 machines and estimated an impact of $5.5 million. And let me bring out another fact or data point. Today, there is many malwares in our systems today, where 90% of an enterprise system is composed of open source software. In that, Malware sits on average in our systems for approximately 275 days. In any of our analog systems today, we would never allow that to happen, but yet we're doing it in our digital systems. We need to start understanding everywhere what is the software bill of materials. It is the fastest growing search item today. What is actually coming into our hardware, our processes, and our people? We need to understand on the right side, how many applications are we actually scanning? How many vulnerabilities have we identified? And how many of those vulnerabilities and malware are we actually mitigating, remediating, and isolating? But we all know that this is a systems of systems approach. The world is made of hardware, Moore's law, networks, Metcalfe's law, and now the software bill of materials. But if we can't stop them at the software bill of materials, we have to go to the next step, which is, let me introduce you to the work from the Florida Institute for National Security and Dr. Forte. Dr. Forte?
Thank you, Ben. Before presenting our technology, which can address some of the issues raised by Dr. Obama, I'd like to briefly introduce the Florida Institute for National Security, or FINS. Next slide, please, Ben. So FINS is a Florida Board of Governors approved institute at the University of Florida since 2023. The University of Florida itself has prestigious designations of being a land, sea, and space grant university. And this shows its commitment to advancing knowledge from a range of disciplines, all the way from engineering to agriculture. It also ranks as one of the largest universities in the United States, with top-notch students, as evident by the SAT scores that I've written on the slide. It's also a leading institution in remote and veteran education, and has been for decades. But something you may not know is that in the last 4 or 5 years, the University of Florida has become an AI university. So specifically, they've created a unique AI across the curriculum, where every one of our students, of the 55,000 I mentioned in the slide, every one of them is exposed to AI in the classroom, whether they're engineers, data scientists, or any other discipline. And the centerpiece for this initiative is the most powerful university-owned supercomputer in the US, which was made possible by the generosity of NVIDIA and NVIDIA co-founder and UF alumnus Chris Malachowski. This supercomputer is known as Hypergator. And this all makes UF a great fit in the national security space. Next slide, please, Ben. And in the national security space, this is where FINS comes in, my institute. So we've emerged to actually support UF's AI initiative, and specifically to extend its mission to national security. And we do so in 3 ways. The first is the development of deployable applied AI in data science. And to do so, FINS has established unique relationships with multiple federal agencies, including the first CRADA in the US with the CIA, a recent educational partnership agreement with the NSA, and CRADAs and EPAs underway with AFRL currently. Second, we're producing talent pipelines for AI and data science knowledgeable professionals who are capable of performing restricted research. I'll discuss this a little bit later in something I call the clearable talent pipeline. And third, we're involved with upscaling for professionals that are already in the workforce. There's an AI deficit of talent, according to numerous reports, and this only exacerbates some of the issues that Dr. Amava raised. Next slide, please, Ben. So to address some of these limitations and these challenges, FINS has developed an integrated hardware, software, and real-time solution, which we call RASC, which stands for Remote Access to Side Channels. This technology uses fundamental physics to complement the software bill of materials, or SBOMs, that Dr. Amaba mentioned, and it fills a unique gap in establishing the resilience of critical infrastructure to cyber attacks. Next slide, please, Ben. Let me start by defining side channel. And to do so, I'll use an analogy. That is the tell of a card player, which is an involuntary gesture, expression, or body language that helps other players infer more about the cards that an opponent may be holding. So the side channels are actually the body language, or the tell, of the hardware itself. So a channel is a media or communication link that has a sender and a receiver. In this case, the sender is the hardware or the system that's running a code. And there are emissions involuntarily from this hardware that leak information about what the system is doing and the data it's processing. This includes things like how hot is the hardware getting? How much power does it consume? How long does it take to perform a computation? What are its electromagnetic radiation and acoustic or sound emissions? And on the opposite end, we have a receiver, who in this case is an outside observer who measures these emissions and uses that to infer some information about the system. Now, typically, side channels are used to perform attacks, but in this presentation, I'm going to discuss how they could be used for defense. So next slide, please, Ben, which shows the RASC, or remote access to side channel, concept of operation, where we measure these side channels to detect anomalies that could be occurring in a critical system that may be missed by these measures that Dr. Amaba discussed, which are preventative. So we consider a critical system that's actually deployed, it's in the field, and it's working, and RASC is essentially a monitor that we put on that system, where that can, instead of relying on the onboard sensors and onboard software, which is monitoring the system, those could be compromised and may not even exist in legacy system. RASC can actually measure its side channels, specifically power and electromagnetic emission, to detect malware, hardware Trojans, and cyber attacks, which are sure to change the system's behavior, and that's going to be reflected in the side channels themselves. So RASC is equipped with things to take these measurements, an hardware processor to actually analyze these measurements at both coarse and fine granularities, as you'll see. And if it detects any unexpected behavior in the side channels, it can use its wireless communication capabilities to send alerts to security administrators. And these alerts can work in conjunction with things like digital twins and AI to determine, first, is an attack occurring? B, is it an unknown attack and what it may be trying to do? And C, what to do in that case. And RASC can actually overcome many of the issues with preventative measures that we have. First, it only needs a baseline of side channels, and in doing so, it could detect both known and unknown vulnerabilities and attacks. It can do so at runtime on a system, and therefore allow systems with known vulnerabilities to operate until the attack is detected, thereby avoiding unnecessary downtime, which would be required to patch most systems. And this is very important for critical systems, which cannot easily be taken offline. That's why they're actually critical. RASC can also tell you how many of your systems are under attack, helping you to prioritize patches and deployment of redundant systems. And last but not least, we've mostly talked about software supply chain issues here, but those same issues actually occur in the hardware supply chain too. Some things like hardware Trojans can also cause changes in side channel behavior, and RASC can partially cover these as well. Next slide, please. So this slide shows first a typical power and EM side channel measurement setup. So you can see that there are these probes on the left-hand side, which are affixed to a stand. You can see a big oscilloscope in the background, which takes measurements at a high sampling rate. And you can see a lab tab on the left, which would be used to process these measurements. This typical setup costs $15,000 to maybe $100,000, and it's infeasible to really use outside of a laboratory. And this leads us to the following question. Can we miniaturize, deploy, and perform side channel analysis in real time for a system? And RASC shows that this, yes, can be done. That's shown at the top portion of this slide, where you can see that the second version of RASC is actually no bigger than the size of a quarter. And it consists of 2 boards with all the components needed to measure, process, and transmit results. And the table at the bottom of the slide compares our RASC version 2 and RASC version 3 boards with a typical setup as well as a commercial board. And while RASC may not be as capable as the typical setup in terms of things like voltage range, sampling rate, and resolution, which are shown in red, it is more than capable and has more than better capabilities such as programmability, remote communication, and real-time processing. It's also small in size and very small in cost, costing less than $400. And that's at low volume, produced at low volume. Now, the next few slides show our malware detection approaches and preliminary results with RASC. Please go on to the next slide, Ben. So this slide shows our first basic test case, code verification flow using Rask. Here we assume that the code executing is completely known beforehand and doesn't change over time. And shortly we'll move on to more realistic scenarios. So what this slide shows is that Rask first measures the power in EM from the, say, microcontroller of your critical system. Then it selects the most important features using a technique known as minimum redundancy and maximum relevance. It linearly combines the two channels, power and EM, using weights that maximize mutual information. This is shown on the right-hand side of the slide. Here it shows that the optimal weight is 0.12, which means that it actually favors power over EM in the analysis. And what these steps do is they help reduce the dimensionality of the problem to avoid overfitting. And it also makes the later tasks in the flow more easy and more lightweight to perform for real-time classification. And that brings us to the next step, which is training. Here we use something like, go back please, Ben. It brings us to use the SBOM code to profile correct side channel behavior and establish basically a baseline for each line of code that's being executed. Then at runtime, Rask monitors the side channels to verify that each of these instructions is being executed properly. In this example, I show sub, add, and jump as 3 instructions. And if they were going correctly, Rask would just check off through the side channels that they are being done properly. Now, if malware gets injected, that's going to change the power and EM traces, which are shown in red. And let's say that actually happened at the add and jump instructions. Rask would detect correctly that the sub instruction through the side channels was operating, but add and jump have been changed to something. Ben, you can go to the next slide. So this slide shows some results from this case for 3 different benchmarks, both with and without malware. And it compares both the offline case, which uses the typical setup, to our 2 versions of Rask. And this was computed or done with a target that's an Arduino board running at 1 megahertz, and that's used as the critical system. Now we can see that the typical setup verifies the code 100% of the time with 0 false positives and 0 false negatives. When we move to Rask version 2, which is operating in real time and has a lower sampling rate and only measures power, it has some false positives, which are shown in red, for all 3 of the benchmarks, and a few false negatives for 1 of the benchmarks. And I've marked these again in red. And Rask version 3, which combines both the power channel and the EM channel, has a slightly higher sampling rate. This can actually match the offline case results, but still do it in real time. Everything is green, and we get very high accuracy. Now go to the next slide, Ben. This slide shows a more realistic test case and a flow diagram for it. Here, Rask actually identifies what instructions are running in a process which we call disassembly. So it starts similar to the previous case, but the features here instead are used to actually train a set of machine learning classifiers for the entire instruction set of the target under test. So because the features also can vary over time due to environmental changes, we also built our approach so that the classifiers can adapt over time, and this is shown on the right-hand part of the slide. Here you can see that the training features and classifier boundary are shown in blue, and at runtime, when we're actually monitoring the systems, these features can actually change, and the changes are basically shown in red. What our adaptive classifier does is it actually moves that blue boundary over to the red boundary in order to do the classification properly. Now, what does the classifier do? It actually predicts exactly what instruction is running per clock cycle based on the side channel measurement in that given clock cycle. Then using the SBOM and a model of the code's proper control flow, we can detect anomalies in the code's execution, which could be a result of a cyber attack or even a fault in the design. And this result can be used to trigger incident response and recovery of the critical system. Alternatively, one can actually send sensor readings and logs of the critical system, which may be used by a digital twin. That digital twin can generate instructions to compare with the ones that Rask predicts to also detect anomalies. And further, the digital twin can also be used to temporarily replace the critical system or see what the impacts of remediations would be on the critical system. Next slide, please, Ben. So this shows a subset of some of our disassembly results for the Arduino that I mentioned earlier. And we use 6 different benchmarks for this. The plots with the blue color show a typical offline setup that's shown in the left-hand side. And the plots with the orange background, which are shown on the right, show the results with the RASC system measurement. Both use more or less the same real-time algorithms for an apples-to-apples comparison, though. And the top row shows the instruction recognition rate versus the number of features that are utilized. And what we see is that the offline setup requires fewer features rather, likely due to its higher sampling rate and resolution. Nevertheless, RASC can actually catch up to the traditional setup's accuracy when more features get used. And the same plots also compare different feature reduction techniques, including our minimum redundancy, maximum relevance one, which is very easy to implement and is very lightweight. We compare that to principal component analysis, which would be more difficult to operate in real time. And we could see that in red and blue, their performance matches quite closely. We can also compare the difference between using power only, EM only with using both. And what our results show in green and black versus red and blue is that when we combine the two, we can actually reach maximum accuracy much faster with fewer features. Now in the bottom row, you can see our disassembly results for 6 different benchmarks over time. The x-axis specifically shows 6 different time points. And between time points 2 and 3 and 4 and 5 on the x-axis, we intentionally restart the critical system, which is going to cause its environment to change. Every time we restart the system, as you can see, there's a little bit of a drop in accuracy due to changes in the environment. But our adaptive methods are able to recover from this, and by the time we get to the next time point, we can recover and actually improve the recognition rates. We also can look at the offline versus RASC results. You can see that the offline results actually saturates to about 90% accuracy in instruction recognition, while the RASC version 3 saturates to about 80% accuracy. So I just want to point out some of the key takeaways here before moving on. The first is that neither of these approaches, offline or RASC, achieve 100% accuracy in the field. And that means that the real-time processing and classification algorithms are actually a lot more critical than the measurement setup, because again, neither of them can get 100%. And something that's not shown that we've done in some of our experiments is that the sampling rate of our measurement system should be about 40 times greater than the clock rate of the system that we're monitoring. And in doing so, you could get close to 100% accuracy in training. This could be used to develop future systems like RASC on systems that operate at faster frequencies. And the other thing I want to point out in the next slide is that we could also combine RASC with other techniques to detect malware and anomalies more reliably. Specifically, what we could look at is the sequence of instructions or more instructions rather than just looking at one instruction in isolation. And that's where the hidden Markov model approach can come in and help out. So what this does is it models hidden states, transitions between these states, and the probability of taking those transitions. Here in blue, we show the states, the arrows represent transitions, and the blue numbers represent, again, the probabilities that I referred to. In our case, the states are actually instructions themselves, and the transitions represent going from one instruction to another in a piece of code. And in this example, what we can see is that the probability of being in state A followed by state B is 90%, while the probability of going from state A or instruction A to instruction C is 10%, and the probability of being instruction D is 0% because there's no transitions to it. Now, since these states are actually hidden, we cannot determine what instructions are actually running on a system without some extra information. And this is done by the observations that the hidden Markov model can also account for, along with their probabilities of seeing an observation in a particular hidden state. So in this case, the observations and their probabilities are shown in green, and the observations in our test case refer to the side channel measurements, that is the power and the EM that we're using to make our decisions. Now, these observations in the hidden Markov models could help us do 2 things. First, they could do state estimation, where we use the observations to determine the most likely sequence of states. For example, If we observe VW, WW, WX, or VX, this indicates that the most likely state sequence was instruction A followed by instruction B. If we observe, say, VY or WY, this indicates that the most likely state sequence was AD, which is not supposed to occur because D is never supposed to be used. So this is an anomaly and something that we can detect. We could also use it for forecasting. So given the current observation, we could try to predict what the next observation is that we're supposed to see. For example, if we observe an X, that means that the current state is either B or C, and therefore the next state, according to the state transition diagram in blue, is either going to be A, which means that the observation should be V or W with equal probability. If we see any other observation next, we know that there's an anomaly and we've detected an attack. I think we can move on to the next slide, Ben. This shows our results of combining the disassembly with the hidden Markov model approach. So we did this on two different benchmarks, and we tested again with and without malware on those benchmarks. And we also compared just the offline case with the RASC version 3, which was the better one from earlier. The hidden Markov model for RASC case is simplified in order to fit it on RASC FPGA, which is doing its processing. And what we observe from this is that even though the offline approaches only had 90% accuracy and the RASC approach had 80% accuracy, with the hidden Markov model, we can improve the accuracy of detection. For the offline approach, we could bring it up to 100%, while with RASC, we can bring it much closer to 100%, but as you can see, there are some false positives as shown in red. With improving the sampling rate of RASC, improving its capabilities a little bit, we're confident that we can overcome this and get it again to 100%. Now to my last slide on RASC, which is a summary. To my knowledge, this is the first ever side-channel disassembly approach that works both in real time and combines power and EM measurements. It's very promising, but it still needs some future work before it actually is deployed. The future work involves upgrading RASC, as I've alluded to perform better monitoring of more complex systems. This could require better classification capabilities, such as using deep learning, which is the state of the art. But it's a little bit difficult to actually incorporate into real-time systems, so that requires more work as well. We could also improve RASC measurement capabilities by increasing its size and cost, adding a digital signal processor, which can handle more complex computations, and include better sensors like better EM antennas. Other things that we want to explore as well are what to do once RASC actually detects an anomaly. So we could, again, incorporate AI. AI could handle analyzing large volumes of data and logs quickly. It could be used to identify the source, method, or scope of an attack. It could also be used to provide forensics based on the information that RASC gives it. It could also be combined with digital twins. AI can recommend preventative measures. Digital twins can actually simulate the impact of those measures on the system itself. And as I mentioned earlier, digital twins can help manage and automate the restoration process and can be used to restore a critical system to its most recent clean slate very quickly and efficiently. We can also look at various actions that we could do, such as containment, mitigation, and deception. And move on to the next slide, please, Ben. So the last part that I'll look at before handing it back to Ben is talent and workforce development initiatives that we're doing at FINS, which could help in dealing with these supply chain and cyber resilience challenges. Next slide, please. So as I mentioned earlier, the University of Florida is developing a curriculum for students which trains them. So we have those students. We also know that there's a talent deficit in the government and in defense and in intelligence agencies in general. And the clearable talent pipeline is something that FINS is doing to basically bridge the gap between these two, UF and these defense positions. So the Clearable Talent Pipeline is a 2-year pilot program funded by the University of Florida, which does the following. It recruits top undergraduates who are US citizens, introduces them to national security problems and how AI could be applied to them, teaches them how to perform research and present it, and puts them in direct contact with members of the national security community who discuss with them the benefits of government service and the challenges in these cyber issues and why their work would be very important. We also put them in touch with agencies and industry sponsors who could give them paid summer internships early in their careers so that they could initiate the clearance process and get that in advance of graduation. This, since we all know the clearance process takes a lot of time, the government and defense industry often loses out on top talent or waste the time in recruiting them. So this could actually help quite a bit there. Next slide, please, Ben. This shows the clearable talent pipeline this year, which was launched in March of 2024. In 1 month of solicitation, we got 107 applications from the University of Florida College of Engineering alone. Most of these applications are coming from computer science. We have others from other disciplines in engineering as well. And as you can see here, we had excellent students. We actually accepted students with 3.85 average GPA, but even the applicant pool had 3.78 GPAs as well. Next slide, please, Ben. So we're actively looking for sponsors of the CTP program who could pay them stipends during the academic year, come to invitation-only recruiting events to get them internships, and so on. But besides the AI that I mentioned earlier, we also have lots of courses at the University of Florida that help expose students to both cyber and hardware security. This includes a very unique world-class lab, which is filled with equipment for education and research for hardware supply chain issues. We've used this equipment to create hardware's bill of materials automatically, reverse engineer chips, and even to detect hardware Trojans. And last but not least, I'll also mention our professional workforce development office, which offers micro-credentials, which are competency-based awards that reflect an individual's mastery of specific topics. We have them in AI, as well as cyber and other areas. We're also looking at a pre-certification course, which we would offer in conjunction with the secure software integration certificate that Dr. Amaba is about to discuss. UF is planning to run a course on this, which would be a prerequisite for that, and this would be a distance learning program, so anybody in the country can take this remotely. Now let me hand it back off to Dr. Amaba to wrap up the talk.
Thank you, Dr. Forte. Really appreciate your work, your research, and what you're doing for the workforce. And to revisit, there's the barcode for the System Software Integration Certificate, sponsored and worked on by the National Society of Professional Engineers, the Society of American Military Engineers, and NICET. Remember the chart. The growth of cybersecurity and vulnerabilities and malware is growing at 742%, and we have to prevent and mitigate what's going on in the United States. We had several SSI contributors, as you can see on the industrial side, from Sonatype, IBM, Lockheed Martin, Boeing, Northrop are just a few that have been going around the US and presenting this data. Associations from the Society of American Military Engineers all the way down to automotive engineers. We have been developing this since 2019 based on the work in 2016. We've completed 9 of the 12 tasks. We are looking for beta exam testers starting in August of 2024. Again, you'll see the details in the QR code. We are accepting applications. We are actually targeting 500 to 1,000 applicants by the end of the year. We believe this is the first line of defense that can not only serve our public, but actually create a new workforce. With that, I will start to close. Why we're here, how we are doing it today, and what we need. As you can see, the PEs, the professional engineers and technologies are our future. To the right, there are nefarious actors or maybe just integrity or bad software that is penetrating our 16 critical infrastructures. The barrier between that is the system software integration and you in the room. Again, the barcode to the bottom or QR code is what we've been doing in Huntsville in details. Every presentation you have seen from the large companies and the societies. And behind us and working with us is FINS, the Florida Institute for National Security, which provides us not only the hardware and integration, but a cleared talent pipeline. And with that, we are ready, Whitney, to take any Q&A. And thank you again to Fox Rothschild, Whitney, Bree, Samantha, the Society, as well as NSPE.
Great. Well, hey, thank you. Thank you to you both for the overall presentation. Really appreciated it. If you have any questions, we can get to a few. If not, we can go over. now, but just real quickly, I'll tee it off. But any question, feel free to put it into the chat. But from your perspective, why would you distinguish open source from any other types of software? Aren't they both equally as vulnerable?
I'll take that, Dr. Forte, and if you'd like to add color commentary, open source software really gave us the best practices, whether it was a web application or a complex ERP, in the capability of reuse. Now, in the ITY words and quality, because of that reuse, we thought there'd be reliability, maintainability, and security, especially with experts. As long as that area was captive and we literally knew the provenance of that code and could have traceability, what I call SMART, very specific, measurable, auditable, reusable, and traceable, we were good. But what happened is, again, 90% of enterprise software started using open source software to again get scalability and compression in time and hopefully quality. But what happened is, as open source software started revolving around the world and open to other individuals with no credentials, it started having a detrimental effect by 2021, because they would do one of two things, right? Either look for the vulnerabilities and exploit it, actually do malware, or the latest technique that Dr. Forte touched on was living off the land, which was even harder to detect, in that they were using the traditional, what was in the packets itself, weren't adding anything. They were using the normal functions and regular code, manipulating them, so we couldn't really detect whether it was functional lines of code. They were using our own code against us. So although the difference in reusability in whether proprietary code or open source code, we're still seeing the same level of vulnerabilities, malware, or integrity. In fact, Standish Group report actually comes out every 2 years in saying that 75%, especially complex systems, fail. It either loses 46% off budget or 82% off schedule. But if you try to use some of the open source best practices, you've got to be aware of the cybersecurity vulnerabilities that we just captured. So currently today, it really hasn't changed as much as we'd hoped for, but that's why we're putting it in the hands of professional engineers today. But great question.
Yeah, I'll just add that the solutions that we discussed today, whether it's software bill of materials or the RAS technology that I discussed, that would apply whether we're talking about open source hardware or proprietary software. So if there's a vulnerability in those, the SBOMs will track it. They'll tell you that there's a vulnerability that's been found, and RAS will detect any vulnerability and let you know that, again, whether it's commercial or whether it's open source.
Got it. Okay, I appreciate that. Well, there are a couple other questions I do have. When we get to that afterwards, I do have a couple of slides. We are coming up against the hour. Do have a couple of slides, SAME slides. I do want to close out, but this has definitely been really appreciative on the. But I do definitely need to touch on some SAME stuff, that we can get back to some of the questions for those who are able to stick around. But again, thank you both for today's session. We really appreciate you both for your time and expertise today. It's definitely very, very informative. But before we wrap up today's program, I'd like to share some of the upcoming events that the DC Post has planned. So please mark your calendar for the local Post events, but also some of the upcoming national events, because we are committed to bringing you more content and fun events throughout 2024. So our next First Friday is going to be on Friday, September 6th. With security considerations in building design from Ryan Searles, who specializes in security and proactive design to mitigate active shooter events, assaults, civil unrest, and other designs and cost-effective solutions for avoiding the potential loss of life and providing overall robust security programs. As always, all registered participants will earn 1 PDH. So registration is now open. And are you interested in sharing your knowledge on current educational topics for First Friday with our members? We are accepting presentations for the fall. So please visit our website and submit your topic abstract today. And sponsorships are also available as well. And please mark your calendar for some upcoming DC Post opportunities. So join us on September 15th for our annual Team River Runner Family Day on the Potomac, with kayaking, boating, and a potluck picnic, sponsored by AFG and hosted by the DC, Mid-Maryland, and DBIA Mid-Atlantic. The event is free and the whole family is invited to come join on the fun. So please register today. And so would you like to hear about the latest updates in infrastructure policy from agency leaders? So please join us on Thursday, September 19th at the Army Navy Club in Farragut Square. There's the latest on policy, planning, and funding from our invited speakers from the Army Corps of Engineers, Coast Guard, Space Force, and NAVFAC. So please don't miss out on this in-person event. And registration is also open for the Scholarship Golf Tournament, set to tee off on Wednesday, October 2nd at the courses at Andrews, at Joint Base Andrews. It's one of 3 armed services at most challenging champion golf courses. Sponsorship is available for this event, so we hope you can join us to fundraise for our STEM scholarship and engineering and construction campers. Last year, we provided over $55,000 in tuition for our STEM students. So we hope you can make a difference by joining us for this event. And so now we have a save the date for upcoming programs for the DC Post. You can see more of these on our website and we have more educational events, First Fridays, networking, business development to help you with your goals throughout the rest of the year. I would like to reach out to a community of 7,000 architecture, engineering, construction, and technology leaders. With the DC Post annual sponsorship, you have the opportunity to leverage our networks and showcase your firm with visibility. So please be able to check out all the benefits on our website in your mission to sponsor the DC Post and your community today. And lastly, we have to join the national SAME community, the largest conference of the year, which is the 2024 Small Business Conference, which is November 20th through 22nd in New Orleans. We look forward to seeing you all today. Registration is open and early bird rate ends on August 30th. And hotel reservations are also now open as well. So again, thank you for all attending the First Friday webinar series with Dr. Amaba and Forte with all the educational topic today. So please be on the lookout for the document delivery with the subject line for slides, your PDH certificate, and the opt-in list of attendees. And we will post the recording on our website later on. So again, thank you all for coming. Make sure you save the chat and have a great weekend. We look forward to seeing you at our next SAME event. Thank you, Dr. Amaba, Dr. Forte. Thank you very much for your time. Really appreciate it. And anything else comes up, we really appreciate. Hope to see you out at a future SAME event.
Absolutely. Thank you so much, Whitney.
All right. Sounds good.
Thank you, Whitney. Thank you, Bree. Thank you, Samantha.